previous lecture, we have seen various network topologies. Now we will solve some problems based on network topologies. Before we start, let's understand what we are going to do today. Upon the completion of this session, we will be able to determine the number of cables or links and the number of ports that are required for a given topology. We will now have a simple recapture on network topologies. The network topologies are bus, ring, star, mesh and hybrid. We shall have a simple recapture on each of these. Now, bus topology. In a bus topology, we will have a common transmission medium and all data traffic will flow through this transmission medium only, and this traffic will be in both directions. Coming to the ring topology, this is a bus topology but in a closed loop, and one more point to note here is that it is a unidirectional communication and all data traffic will flow in one direction only. Coming to the star topology, we will have a central node, maybe a switch or a hub, and each device will be connected to the central node. Coming to the mesh topology, every pair of nodes will have a dedicated line. If there is a node, every node will be connected with its other nodes through a dedicated link. And coming to the hybrid topology, a hybrid topology is a combination of one or more topologies. In this case, here is a bus topology which is connected to a star topology, and in turn this is connected to a mesh topology, and that is why we call this as a hybrid topology. Now we will move on to the questions. Question number 1. Identify the given topology and determine how many cables and ports are required to have such network. We are given with a topology and we have to identify what is this topology. And the answer is very simple. This is a ring topology. How many cables and ports are required to have such network? Let us formally solve this question. In a ring topology, if there are two nodes, then we need two cables. This is cable 1 and this is cable 2. And each node needs two ports. This is one port and this is port number 2. Similarly, this node also should have two ports, port 1 and port 2. So total of 4 ports are required. Each node must have 2 ports. So that is what is given here. So I have created a table like this where the number of nodes are listed, how many cables are required, the number of ports per device and the number of ports in the network. This is my own way of representation, and if you want you can use a different notation. If n is the number of nodes, if there are 2 nodes and we need 2 cables. So that is why I have used n in both the cases. The number of nodes is equal to the number of cables in ring topology. This will not be the case for all topologies. So if there are 2 nodes, we need 2 cables. And each node must have 2 ports. And that is why I have mentioned 2 here. And a total, there are 4 ports required if the number of nodes are 2. Some may have a question in their mind. One cable is enough for this scenario. Why do we need 2 cables? Actually, we aren't concerned about peer-to-peer networking. And this is a ring topology. A ring topology means that should be closed. It means there should be a cycle. Now we will see a ring topology that involves 3 nodes. Now this is an example scenario that involves 3 nodes. If 3 nodes are involved, then obviously 3 cables are required. That is what I have mentioned here. 3 nodes, it needs 3 cables. And each node must have 2 ports. Number of ports per device is equal to 2. And therefore, 2 into 3, 3 nodes, 2 into 3 is equal to 6. A total of 6 ports are there in the network. Now we will see if the number of nodes is 4. If there are 4 nodes in a ring topology, then 4 cables are required. Cable 1, 2, 3 and 4. And each node must have 2 ports. And the total of 2, 2, 2, 2. So 2 plus 2 plus 2 plus 2. So a total of 8 ports are required. If there are 100 nodes in a ring topology, and it is very difficult to manually draw 100 nodes and solve it. So we need a formula to do this. The generic formula is, if there are n nodes, then we need n cables. Each node must have 2 ports. Therefore, the number of ports, total number of ports in the network is equal to 2 into n. So I have given a formula. Total number of ports is equal to number of nodes into number of ports per device. This is number of ports per device. As far as ring topology is concerned, number of ports per device will always be 2 only. So it is fixed as 2, and 2 into number of ports will give you the total number of ports. We will revisit this question again. Identify the given topology. We have identified this. It is a ring topology. And now we will determine how many cables and ports are required to have such network. And the solution to this is, it is a ring topology. And here the number of nodes are 6. This is 1, 2, 3, 4, 5, 6. So there are 6 nodes, and that is why I have mentioned as n is equal to 6. If n is equal to 6, then the number of cables that are required is also 6. We know that if n is the number of nodes, then the number of cables that are required is also 6. Therefore, we need 6 cables in a ring topology. For this topology, now we will see how many ports are required. We know very well the total number of ports is equal to the number of nodes into number of nodes per device. We know number of ports per device is equal to 2, and the number of nodes is equal to 6. So n is equal to 6 and number of ports per device is equal to 2. So when we solve, the total number of ports in the network is equal to 6 into 2, which is equal to 12. The answer for this question is, it is a ring topology and it needs 6 cables and total 12 ports are there in this network. Now we will move on to question number 2. Traffic problem can be minimized using A star, B bus, C ring and D mesh topology. We have to identify in which topology there is minimal traffic. This is a star topology, this is a bus topology, this is a ring topology, and here is the mesh topology. First we will check whether there is a traffic problem in star topology. In star topology, all nodes are going to send traffic or data to the central hub. Obviously, traffic is high in the central node. So, star topology is not the answer. And coming to the bus topology, we know very well that it is depending on the common transmission medium and all nodes are going to use this common transmission medium. And it is a bidirectional communication too. So, traffic problem is there in bus topology also. So, this is also not the answer. And coming to the ring topology, we know very well that it is a unidirectional communication and all traffic will be in this direction only. Suppose if this is going to send some data to this device, it cannot send this way because if the traffic pattern is like this, then it has to send in this way only. Similarly, all devices will be sending their data in this pattern only. So, traffic problem cannot be minimized using ring topology. And coming to the mesh topology, every pair of nodes have a separate line or a dedicated line or a dedicated channel. Since every pair of node has a dedicated link, so there is no traffic problem in this case. Suppose if this wants to send some data to this node, so it uses this line and this is a dedicated line that is exclusively for these two nodes. And if this node wants to send some data to this node, it uses this dedicated line. So the answer for the question is, traffic problem can be minimized using mesh topology. The answer is mesh topology. Now we will see question number 3. How many ports and cables are required for a star topology? In a star topology, there will be a central node. Every node is connected to the central node. So if we observe, we will say there are 1, 2, 3, 4, 5 ports. If there are 5 devices, we will say there are 5 ports. But that is wrong. Because this central device also should have a port. If we are concerned about only particular node, then it needs only one port. But in the entire scenario, there are 10 ports. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So there are 10 ports and there are 5 cables. It is very easy to solve it if the scenario involves a very small number of nodes. But we have to formally solve it. If n represents the number of nodes, then the same number of cables are required. We can evidence this example. 1, 2, 3, 4, 5 nodes and 1, 2, 3, 4 and 5 cables. So if it uses only 2 nodes, it uses 2 cables. Similarly, 3 nodes means 3 cables, and each node will have one port. So the number of ports will be 1. But do remember, we have to focus on this part also. So I have given a generic formula. Total number of ports is equal to 2 into n, where n is the number of nodes. If our network involves only 2 nodes, we need 2 cables, and we know very well that every device will have one port. The total number of ports will be 2 into n. In this case, n is equal to 2. So 2 into 2 is equal to 4. If 3 nodes are involved, we need 3 cables, and every device will have one port only. And total number of ports is equal to 2 into 3, which is equal to 6. If there are 4 nodes, then there will be 8 ports. If n nodes are there, 2 into n is the total number of ports. The answer to question 3 is, if there are n nodes and we need n cables. In this case, n is equal to 5, so we need 5 cables. And the number of ports is equal to 2 into n, where n is equal to 5 in this case. So 2 into 5, which is equal to 10. The number of ports 10 means the ports involved in the n devices as well as the intermediary devices. There is a homework problem for you. Assume 6 devices are arranged in a mesh topology. We are required to find how many cables are needed, how many ports are needed for each device, how many ports are there in the entire network. Derive a formula and post your answers in the comment section. I hope now we will be able to determine the number of cables or links and the number of ports required for a given topology. I hope the session is informative and thank you for watching.